Linear functions are also commonly known as linear equations. We've looked at linear relationships, displaying them in both tables and graphs. However, using tables and graphs to estimate the value of a variable can be time-consuming and inaccurate, especially if we need to find a non-integer value on a table or grid that doesn't have sufficient detail. Using a linear function or equation is a more accurate way to describe the relationship between two variables. Remember from the last video that a linear relationship has both independent and dependent variables. If a straight line has a gradient m and a y-intercept c, the linear equation connecting x and y has the equation y equals mx plus c. Using the equation above, y must be the variable. Which variable? The dependent variable. Why, you might ask? Because it's the variable that's being solved for. Remember our taxi cost example where it costs $5 to enter and $2 for every kilometre travelled? This can be written as a linear function. Again, if we graph the function, we can visualise y as the y-intercept and the gradient, or the rise over run, is 2. We know that the taxi cost line passes through 0.5 and 1.7, so the gradient is calculated. Y step over the x step, which is 7 take 5 over 1 take 0, that equals 2. The y-intercept again is 5, therefore for the equation y equals mx plus c is y equals 2x plus 5. If we're given the value of one variable, we can substitute this into the equation to find out other variables, or the total cost. If you substitute the distance in for x, you can work out the total cost y. I'll let you try this one for yourself. Here we have the height of a candle burning for a certain number of hours. Find the equation of the linear function connecting x and y. So we need two bits of information. We either need the gradient and a point on the line, or 2 points on the line. We don't have the gradient yet, but we can use that. We can use 2 points on the line to find the gradient. 0, 90 and 10, 50 pass through the line, and therefore we can calculate the slope as -4. The y-intercept is 90. This is all the information we need to work out the equation of the line, which is -4x plus 90. Now we can use this equation to find out other information. So you will see that 12 hours isn't on the graph, but we can use the equation of the line to work out x equals 12 hours. We can substitute that into the equation and work out the height of the candle after 12 hours. Solving the equation, we get 42 millimeters. So the height of the candle after 12 hours is 42 millimeters. Now we can calculate how long it will take for the candle to burn out. That's when y equals 0, or y equals 0 millimeters. We can substitute that into the equation and solve for x. Then we get 0 equals -4x plus 90. We can subtract 90 and rearrange the equation, and we get x equals 22.5 hours. Are the following equations linear? The top two, slightly different form to what we're used to. However, they still have two variables and are still linear equations. These are in what we call the general form. We'll look at that a bit further later. The last one is in a familiar form and is linear. That's all for today. Thanks.